Okay, get this. The data is sent across the network to the other computer. 9 out of 10 students are going to write that exact vague answer on their exam and just quietly lose all their marks. It is a total classic trap, and honestly, it happens every single year. So let's look at this mistake right now, before you actually make it.
Welcome to This Explainer. Our mission today is to completely fix this grade-killing habit. We're going to be using a universal, multi-layered framework built specifically for the Cambridge Igcse Computer Science 0478 syllabus. Seriously, we are going to totally transform how you tackle these exam questions.
All right, here's our tactical briefing for today. We'll be covering mastering packet switching, the CPU cycle unlocked, HTML application strategy, the programming ecosystem, and finishing up with a final exam challenge. Our goal is to take you from everyday language straight into structured, high-scoring exam responses across all these topics.
So let's jump right into Section 1, Mastering Packet Switching.
Now think about this for a second. If an examiner asks you to explain routing or packet switching, how do you answer that without losing marks for being too vague? Like, how do you actually prove you understand the mechanics of it?
Well, to master this, we use 3 distinct layers. Layer 1 is the practical purpose, so identifying the everyday digital problem that packet switching actually solves, like connection issues. Then, Layer 2 is technical precision. This is where we swap out that everyday language for correct subject vocabulary. And finally, Layer 3 shapes that technical knowledge to directly address the examiner's specific marking criteria.
We really need to hammer home these 3 specific steps. First, define the problem. Second, use precise technical vocabulary. And third, structure it for the examiner. This is exactly how you transition from a fuzzy, vague idea in your head to a syllabus-safe answer on the page.
And this is a brilliant tool right here. Before you write down any answer, run a what, how, where, why, 4-question self-check. What is it? How does it work? Where is it used? And why is it chosen? Doing this logically sequences your explanation, so you literally do not miss a single mark.
Because, honestly, upgrading your vocabulary is exactly what secures those top marks. Instead of using vague words that trap so many students, words like data, or raw facts, or checking input data, you need to use precise examiner terminology. Think words like information, or processed, meaningful context. That's what they're looking for.
Moving right along to Section 2, the CPU cycle unlocked.
The most common pitfall here isn't actually a lack of knowledge. It's jumping steps. Students frequently lose points by just dumping random facts onto the page instead of presenting a strictly logical step-by-step sequence of operations.
So to avoid that whole jumping steps trap, start with your everyday language, and then deliberately force that into technical vocabulary. You want to identify the exact hardware components involved, like the control unit, or CU, and the arithmetic logic unit, the ALU, and mentally map out the strict sequence you have to follow.
Just to recap your structured solution path for the CPU cycle, identify and classify the components, sequence them in strict logical context, and run your what, how, where, why 4-question self-check. This high-scoring strategy absolutely guarantees that your mechanism connects directly to its consequence in whatever exam scenario they throw at you.
All right, let's shift gears a bit. Section 3, HTML application strategy. Okay, be honest with yourself when you sit down to an HTML question. Are you just describing what the code looks like, or are you actually explaining its purpose within the specific scenario the examiner gave you? Because there is a massive difference in how many points you'll get.
Doing this right requires a 3-step technical method. First, you identify and classify the HTML concept. Next, you logically sequence the HTML structure step by step. And finally, you create a contextual connection. Basically, link your explanation back to the specific scenario they provided, whether it's a retail site or a banking portal.
So, the absolutely crucial point here is knowing your command words. If the examiner uses the word describe, they just want the characteristics, the details, and the structure. But if they say explain, well, that demands reasoning. You have to give the how and the why based entirely on the scenario.
That brings us to Section 4, the programming ecosystem. Okay, before we even look at programming structures, you need to burn this rule into your memory, the 1 mark, 1 point rule. 1 mark equals 1 distinct technical point.
Please, do not waste time repeating the exact same idea in different words. The examiner is not going to give you double credit for it.
Now, to scaffold your programming skills, going from basic sequence to selection and all the way to iteration or looping, you want to apply a 4-step framework, regardless of what language you're using. State the core concept, provide evidence, apply scientific reasoning, and use precise examiner wording to secure those top marks.
And hey, speaking of precise wording, never fall into this classic trap. Validation checks if data is reasonable, like doing a range check. Verification, on the other hand, ensures the data entered matches the source exactly. Mixing these two up is a super common generic answer trap that examiners are actively looking for.
All right, time for Section 5, Final Exam Survival Challenge.
Listen to this simulated exam response. The system uses validation to ensure the password was typed exactly as the user intended. I am putting you on a 10-second mental clock right now. Can you spot the fatal terminology error here?
Okay, time's up. Did you catch it? Here is the red pen correction. The fatal error is using the word validation. The correct, syllabus-safe phrasing required here is verification, because we are ensuring the password entered matches the source exactly. Validation would only check if it met the password rules, not if it was typed the way the user actually intended.
If you caught that mistake, awesome job, you're already thinking like an examiner. That is exactly how you master Igcse Computer Science 0478. You understand it, you don't just memorize it. Make sure to subscribe to our YouTube channel Ace the Exams at acetheexams_Igcse to really excel in your Pambridge exams. Until next time, ask yourself this. If you were designing the next exam paper, what subtle trap would you set for the unprepared student? Keep learning, and I'll see you in the next explainer.